Good day, everyone. Welcome to ICT Online Learning. For this day, let us proceed to the next chapter, that is atomic theory. Okay, so for that, we have this one. So the idea of an atom, which is the smallest particle of matter, has intrigued mankind since the beginning of civilization. Throughout the centuries, the view of the atom has changed. New ideas and new technologies have influenced the model of the atom. This view of the atom is still a theory, and therefore it is still subject to change. The modern model of the atom is called the quantum model. The chart below summarizes the various atom models that have been developed during the course of history. So by the way, in this topic, we will recognize some scientists as well as the name of the model, sketch, and the idea of the theory, also the importance and the improvement, as well as the problems and the shortcomings. Why was it changed? Okay, so let us start with the first one. So he is Democritus in 300 BC. Okay, so the name of the model, that is the atom, the indivisible particle. Atomos in ancient Greek means that which cannot be further broken down into smaller pieces. Some importance and improvement on previous model. So talks about the atom as the smallest particle of matter, defines the atom as an indivisible particle, and explains certain natural occurrences such as the existence of elements. And some shortcomings, problems, or why was it changed. So does not give a scientific view of the atom, only a conceptual definition. Second one, does not talk about subatomic particle, which is electrons, protons, and neutrons. Next one, so he is John Dalton in 1800, which is the name of the model sketch, that is the solid sphere model, wherein the atoms are seen as solid indestructible spheres, just like billiard ball. Then we have also the importance and improvement. It also explains a lot of chemical properties such as how atoms combine to form molecules, explains chemical change better than the particle theory, and confirms the basic laws of chemistry, law conservation of mass, at the same time the definite proportions. And some shortcomings and problems, or why was it changed, does not include the existence of the nucleus, does not explain the existence of ions or isotopes, and does not talk about the subatomic particles, which is the electrons, protons, and neutrons. Okay, next one. So he is J.J. Thomson in 1850. So the name of the model, that is what we call the racing band or the racing band model, or the chocolate chip cookie model. Atoms are solid spheres made up of a solid positive mass or core with tiny negative particles embedded in the positive core. Then some importance and improvement. So infers the existence of electrons and protons, introduces the concept of the nucleus, and infers on the relative nuclear density and atom mass of different atoms. And some shortcomings and problems. Why was it changed? Does not explain the existence of electrons outside the nucleus, does not explain the role of electrons in bonding. Okay, so that is under the development, which comes from this particular scientist. So he is J.J. Thomson. Next one, so we have here this one. So he is Ernest Rutherford in 1905. So the name of the model is the planetary model, which is the famous gold leaf experiment. Proves that the nucleus is positive and the electrons are outside the nucleus. Now, some importance and improvement. First, real modern view of the atom explains why the electron spins around the nucleus, or the Bohr contribution, and proposes that the atom is really mostly empty space. Then some shortcomings and problems. Does not place electrons in definite energy levels around the nucleus. Does not include neutrons in the nucleus. And the last one is does not relate the valence electrons atomic charge. Okay, so that is the development under this particular scientist, Ernest Rutherford. And another, so we have this one. So he is Niels Bohr in 1920. Okay, so the name of the model, sketch, and main idea of the theory that is the electron in definite energy levels around the nucleus. Use atomic spectra to prove that electrons are placed in definite orbitals called the shell. So again, if we say shell, that is the orbit located outside the nucleus of an atom. Okay, now what are the importance and improvement? It explains the role of valence electrons in bonding, relegates the number of valence electrons to the periods of a periodic table, and places electrons in definite energy levels. So we have here one. We have a 2 electron in the first, 8 electron in the second, and 18 electron in the third. Now, how about the problems and shortcomings? So it does not explain the shape of molecules or other abnormalities that form unevenly shared pairs of electrons, such as the abnormal behavior of water, the difference in carbon-to-carbon bonds between diamond and graphite. Okay, so those are the development under this particular scientist. So again, Niels Bohr. Okay, so I think for that, so thank you so much for watching and hope to see you in our next video. Have a good day to everyone.
For more ICCT College's video updates, please subscribe and click the notification button.